Consider the function given by f of x equals x cubed minus 4x plus 2. Do me a favor, let's change this up a little bit and say this is x cubed minus 3x. Okay, all right. Help me out. Change it to 3x. I think the number will work out pretty nicely for us. So if you need to find, let's say, critical values, anytime you run into problems that says find critical values for a polynomial function like this, see, this is not a fraction function, just a single line polynomial function, set the derivative equal to 0. Set f prime of x equal to 0 and solve for x. Okay? So you'll need to find the derivative first. So what is f prime of x? That will be 3x squared minus 3, right? Now, what you do is you set this equal to 0. 3x squared minus 3. I will have to, you know what? I will try to factor this. Okay, I'll try to factor it and solve it. Okay? If I factor out the greatest common factor of 3, I will have x squared minus 1 left. Now, we can factor that using difference of squares as difference of squares, which will be x plus 1 times x minus 1. So, if I solve this, we get two critical values. X equals -1 and x equals +1. So, that's how you can find critical values. You find the derivative, you set it equal to 0, and you solve for x. Okay? Now, if it's asking for us to find any relative extrema, using the first derivative, we will have to sketch a number line. Okay, look, sketch a number line, and what you will do is plot your critical values, -1 and +1. Okay, what you will do is test some points to the left and right and in between. Okay, now remember, the first derivative is negative if the function is decreasing, right? The first derivative is positive when the function is increasing. Okay, so what we will do is we will plug in numbers into that first derivative, which was f prime of x equals 3 times x plus 1 times x minus 1. So look, what will happen if I pick a point that is to the right side of 1? So I'm gonna pick x equals 2 here. Because 2 is bigger than 1, it definitely is on the right side of 2, right? So if I plug in 2, let's see the sign of this. 3 times 2 plus 1, 2 minus 1. If I do this multiplication, I will get 3 times 1. And look, this is a positive number. So what we just got is the function will be increasing to the right of 1. Because the sign of the derivative came out to be positive. If the sign was negative, I would have said decreasing, okay? But that's what we will now have to do for all the other sections, okay? So what is a number that is in between -1 and 1? I will use 0, okay? I will pick 0 for this interval in the middle. If I plug in 0 in there, I will get 3 times 0 plus 1 times 0 minus 1. That is 3 times 1 times -1. Now look at the sign of that. That comes out to be negative. Therefore, this function must be decreasing in between these two numbers. Okay? All right, we just have one more interval left, right? So we have to pick a number that is smaller than -1 this time because that's to the left of it. So pick, I will say x equals -2 because that's to the left of it, right? So if I plug in -2, what will I get? 3 times -2 plus 1 times -2 minus 1. That is 3 times -1 times -3. Well, if I do negative times negative, that will give me positive. So we are looking at an increasing interval again because the first derivative came out to be positive. Okay? All right. So we know that much. So I may be able to sketch a picture here, okay? Look at this for me. Draw a line going up. And this is where I stop for a second, right? because now I need to be decreasing from that point. I'm going to go down. All right, I went down and I'm going to stop right there. And then make the graph to go back up. All right, there we go. Here's a picture of a graph. And I can find the relative extrema now, okay? So look, in between green and orange, we have a relative maximum. Relative maximum is at x equal -1, right? That's the max. And we have a relative minimum at x equals +1, okay? Because that's when the graph stopped going down and started going up. So that's the bottom of this graph, okay? That's the lowest point in this region, okay? F is increasing over the interval, the green and red, right? Green one was -infinity to -1. And the union symbol for the other interval, it was also going up from +1 to infinity, okay, forever to the right. Now this graph was decreasing from -1 to +1, right? And it does have a relative minimum at the point. Now it looks like they don't want just the x value because we know where the relative minimum happens. We know it happens at +1, right? Because that's the lowest point. But when they say point, they want us to find its y coordinate. So if you want to find the y coordinate of x of 1, we need to go back to the original function and plug in 1 into the original function. So what's f of 1? I'm plugging into this one now, right? So that will be 1 cubed minus 3 times 1 plus 2. Okay, so if they want point, you have to go get them their y values. So if I do 1 minus 3 plus 2, well, that comes out to be 0 for the y coordinate. So after doing this, you may be like, did I do it right? Because we graphed it completely graphing calculator free. So I might open up a graphing calculator to see if we got it right. Desmos graphing. So the function that I rewrote was f of x equals x to the 3rd power minus 3x plus 2. Do we have a relative minimum at 1, 0? Yes, we do. And we do have a maximum at -1. We just never found the y value of 4, but we could have easily done that, right? But yes, this matches my graph. Mine is just a little bit fatter, okay? So, no. But we got the turning points right, okay? And that is something that we couldn't figure out in pre-calculus. And this is something now we get to be able to do because we know something called the first derivative test. Okay, I'll actually stop this video and show you example 2 in another video. Okay.